We are going to look at a basketball problem today and how that relates to quadratics. So we're going to start by looking at a video, and then we're going to fill out this worksheet that deals with his stats and quadratic formula.
I'm Elton Brand. I'm a power forward in the NBA. I'm here in my hometown, Peekskill, New York, visiting my old high school. I started playing basketball when I was about 5, 6 years old, and I was really, really bad. But learned the game and kept working at it and got better and better as I got older. I started out high school on the junior varsity team. Then the coach from the varsity team brought me up to that level. The following 2 years, we won the New York State Championship, which put me on the national spotlight and my team. So after high school, I accepted a scholarship to Duke University, got to college and played really, really well and became the #1 pick out of all the collegiate players and got drafted by the Chicago Bulls #1 overall. And it was a dream come true. As anyone that follows sports statistics knows, there's a lot of math in basketball. Free throw shooting is a skill that every basketball player has to work on. I don't constantly think about the math behind it when I'm playing a game. But when I was younger, understanding math helped me improve my performance. 3 key variables can influence your shot. First is the release height. Second is the ball's initial vertical velocity, a rate that includes the angle and speed of the ball as it leaves your hand. And the third is gravity, which makes a basketball accelerate as it falls. You can use these variables to figure out the height of the ball at any given time. And knowing that, you can tell if you'll make the shot. When I shoot a free throw, my goal is to maximize the height of the ball so it has the best chance of going in. Your challenge is to use the 3 key variables and my stats to figure out the maximum height the ball reaches on its way into the basket. At release, my average initial vertical velocity is 24 feet per second.
All right, let's write that down. 24 feet per second on the worksheet. So initial vertical velocity v sub 0 equals 24 feet per second.
My average release height is 7 feet.
All right, let's write that down. Average release height, 7 feet. Let's see what he calls it here.
The free throw line is 15 feet from the backboard.
All right, 7 feet.
The height of the basketball hoop is 10 feet off the floor, and the rim is 18 inches in diameter. And finally, you can find the height of the ball at each point in time by combining the 3 key variables. The acceleration of gravity, which is -32 t squared, but in this case, you'd use only half for downward pull, or -16 t.
All right, -16. -16 feet per second squared will be his downwards acceleration.
T squared. The initial vertical velocity, which you'd multiply by time to get the distance traveled and the release height. All right, get to work.
All right, so now we're going to look at using those, combine these 3 key variables used to calculate the ball's height, h, at any given time t, by setting up this equation. So h of t equals our downwards acceleration, -16 t squared, plus the initial vertical velocity, plus 24 t, and then his release height, plus 7. So we can graph what sketch a graph of what the situation looks like. So if we have our 2 variables, his height over time, and then his time in seconds, this is in feet, and he starts at 7 feet, it's going to go up and then down. So the question is, at what time does the ball reach 10 feet? What strategy would you use to calculate the values of time when the ball reaches a height of 10 feet? So, and again, in our equation, we want to know when this height right here is 10 feet. So we can make our equation, let me go back here, 10 equals negative 16t squared plus 24t plus 7. And then we can solve. So it's a quadratic. There's many different ways you could solve. You could set it equal to 0 and try to factor it. You could use quadratic formula. We could also look at our graphing calculator. So let's start with quadratic formula since that's something that we've practiced this unit. So quadratic formula, first step is you want to get 0 on one side first. So we have 0 equals negative 16t squared plus 24t minus 3. We can identify a, b, and c. A is the number next to the t squared, so negative 16. B is the number next to the t, and c is the number by itself. And then we can plug this into quadratic formula to find out which time does our height equal 10 feet. So I'll need more room for this. So we have our time, I'll call it x, but it should be t. We'll use t then. T equals opposite b, so negative 24, plus or minus the square root of b squared minus 4ac all over 2a. So a is negative 16 and c is negative 3. Actually positive 3. Oh, negative 3. All over 2a. And a was at negative 16. All right, so if we calculate that, again, I want you to calculate the three different parts, this part, and this part separately. So you have negative 24 plus or minus the square root. And let's type this in, our calculator. So put it in as you see with the parentheses. So we get 384 all over negative 32. And then you're going to break it up into your two answers. So negative 24 plus the square root of 384 divided by negative 32, about 0.14 seconds. And let's do negative 24 minus the square root of 384 divided by negative 32, 1.36 seconds. So if we think about, here's our 7 feet that he started out with. The ball goes up and then it comes back down. You can see why there's two answers because, again, we're looking for when it's about 10 feet. When the ball is 10 feet in height. So after 0.14 seconds and also after 1.36 seconds. So there's two times where your ball is at a height of 10 feet. Solve your problem, which we did, show all your steps. You may use the graph on the last page or show your work in the space below. So here's the work that I would want to see. Quadratic formula, find your three numbers, get your two answers, and then here's what an example of your graph might look like. Okay, so our solutions, we had two of them, about 0.14 and 1.36. 0.14 and 1.36 seconds. How could we find that same certain height on the calculator, or how could we find that height on the calculator? We could graph it. So let's open a new graph page. Let's type in our quadratic, which was negative 16, and we have to use x in the quadratic instead of t, but negative 16 right here, x squared, oops, let's go back, and it was his plus 24x, his initial velocity, plus his initial height, 7, and then we can see what this graph looks like. And we want to know when it equals 10 seconds. So what we could do is, if I hit tab and go up, subtract 10 from each side. So this should be a minus 3. Hit graph. Okay. And now let's see when this height, actually when we solve here. So again, what I did was put a 10 over here, subtract it from each side, and now we're looking for the zeros because we'll have 0 on one side. So if we analyze our graph, we want to find the zeros, and there's two of them. So here's the first one at that 1.4 about, and if I go to menu, analyze graph, again we're looking for a 0. And again there's that 1.36. So we can do it on the graphing calculator by setting equal to 0, graphing the quadratic and finding the zeros, or we could use quadratic formula, again setting it equal to 0 and solving using quadratic formula. So again, how could you find time at a certain height? Plug in that height, but then get 0 on one side, and then you could plug it into your calculator. At what time does the ball reach the maximum height? Again, what strategy could you use to find the maximum height? Well, that's the vertex. So again, if we have our picture right here, it's the vertex, and we know to find the x value of the vertex, that's negative b over 2a. And then we could plug that into our quadratic and find the y value. But we just want to know at what time. So this is the time, negative b over 2a. So again, if we go to our equation, let's just plug in. Our b is 24, our a is negative 16. So let's go back here, and our time will be negative b over 2a. And again, our b value, 24, a negative 16. So if we plug in negative 24 over negative 32, and then if I get that fraction, let's change our fraction to a decimal. This is about 0.75 seconds. So at 0.75 seconds, our ball has reached our maximum height. All right, so again, maximum height. It says round to the nearest hundredth, so that's 0.75 is the exact, actually, answer. All right, what is the maximum height of the basketball? Well, we know our time, so let's plug into h of t equals, what was our equation, negative 16t squared plus 24t plus 7. We're going to take this and plug it in for t here and solve. So we have negative 16 times 0.75 squared plus 24 times 0.75 plus 7. And if we do that, I'll do it on my calculator. And again, use your parentheses. And we should just be able to type it in exactly as we see it. And I get I get exactly 16. So this will be 16 feet in the air. And now my workspace quit on me. Let's start it again. Quit. Okay, so here the maximum height of the basketball was at 16 seconds. Again, my workspace is not going to work. Let's see if I can get it working. Try one more time. And let's force quit this. Okay, so again, your solution, the maximum height of the basketball will be at 16 feet. How could we have done this on our calculator? Well, we could type it in. I'm gonna change this equation. This was at 10 feet. So if I go back up to tab and go back up to plus 7, that was his initial release height. And we want to find the vertex of this right here, the highest point. So I'm going to go to menu, analyze graph, and let's find our maximum point, the vertex here. And you can see at 0.75 seconds we reach a height of 16 feet. And then the last question, if there was no hoop, when would the ball land on the ground? So again, what we're doing is we're figuring out when is the height 0. So we can use quadratic formula for this function. H of t equals negative 16t squared plus 24t plus 7. And we set that equal to 0. And let's use quadratic formula and solve. So here a equals negative 16, b equals 24, c equals 7. And we could plug into quadratic formula and solve. So x, or t, equals opposite b plus or minus the square root of b squared minus 4ac, negative 16, 7, all over 2a. That was negative 16. And again, calculate these three separately. I'd want to see that work. X equals negative 24 plus or minus the square root of the discriminant all over negative 32. Let me calculate this. So we have 24 squared minus 4 times negative 16 times 7, and that'll be 1024. And then you're going to break it up and do negative 24 minus the square root of 1024, hit enter, divide by negative 32. So one of the times is at 1.75 seconds. And then the other is at negative 24 minus the square root of 1024. Hit enter, divide by negative 32. Okay. Negative 24 minus 1024. Alright, negative 24 plus. Okay, so one of our answers, this one was wrong. One of our answers is negative, and I'll show you what that means on the graph, negative 2.5 seconds. And one of our answers is positive. Let me recalculate that. Minus square root of 1024 divided by negative 32. Okay, 1.75, so that was right. Okay, so we have a negative answer, and what that means is, remember, he started at a height of 7 feet, so if we do our quadratic, it starts negative and then goes up and then goes down. So we have our two zeros here. One is negative, one is positive. So in this situation, the only answer that makes sense is the positive. So this is when the ball will hit the ground at 1.75 seconds. All right, and then the last step is, okay, so the time the ball reaches a height of 0 feet is 1.75 seconds. The horizontal distance that it has traveled, well, we could plug that in to h of t equals negative 16t squared plus 24t plus 7. If you plug in the 1.75 in here and here, which I'm not going to do that for you, you'll figure out the horizontal distance that is traveled after 1.75 seconds. How could you find when and where the ball will land on the calculator? Well, again, we're just looking for the zero. So let's see what okay, here's the equation. It's typed in. And we want to figure out what this point is. So that's one of our zeros. So again, if we plug in, let's see, go to menu, analyze graph, and I think it's already the 0. We already calculated that. Yep, so at 1.75 seconds, it reaches a height of 0. So I was wrong here. It says, what is the horizontal distance our ball has traveled? Well, this, if we plug the 1.75 in, that's not the horizontal distance. That'll be the vertical distance. So let's take out this right here. All right, so the ball reaches a height of 0 feet at 1.75 seconds, and we can calculate that by looking at the 0 of the function. So your assignment will be to answer these same questions, except I'm going to give you different starting initial velocities, different starting heights, and you're going to have to be able to calculate the vertex, the highest point of the ball, and the zeros as well.